Welcome to Programming Knowledge. Today I will introduce you about what is FreeRTOS and how to set up it on Arduino in this video. Okay, first of all, FreeRTOS right here stands for Free Real-Time Operating System. Okay, this operating system is used for embedded devices. As you know, most operating systems appear to allow multiple programs or threads to execute at the same time. This is called multitasking. Okay, in reality, each processor core can only be running a single program at any given point in a time. It means operating system will handle application, then serve for application if move to monitor, printer, mouse, keyboard, and left all the time. But the short interval time between two applications only in milliseconds. It's very short, so it seems to be concurrency between all applications. FreeRTOS is a real-time operating system, and this is a simple, popular OS for embedded system or embedded devices that has been ported to 35 microcontroller platforms. It is distributed under the MIT licenses, so it's free. And the short time I told you is the tick method at regular short interval. The thread tick method switches tasks depending on priority. You can set a priority for application, monitor, and all the tasks in your code. And it's your round-robin scheduling scheme. Operating system in embedded devices usually use round-robin to handle the task. Maybe we use semaphore, but it's a little bit. And the FreeRTOS will help us easily handle our program via task. Okay. Right here. This is the FreeRTOS on Arduino. The Arduino community on the world has developed this OS for Arduino. It's very popular and strong in embedded devices. But in this video, you don't need to connect your Arduino to computer, because I will use FreeRTOS in some next video, and I will show you how to set up your shortcode, run the program with FreeRTOS. In this video, I only show you how to set up and download the library of FreeRTOS on the internet. Okay, and here there are two ways to download the FreeRTOS to your Arduino. The first one is from GitHub. You can follow this URL and download from GitHub by a zip library, or we can download from the library managed in Arduino IDE. Okay, first I will show you how to download from GitHub. Right here, only download is the original version 4 years ago from Richard Berries. Okay, clone or download right here, download as zip file. Okay, I will put it in desktop, and then I will open the Arduino IDE. Just browse to this link like this. Sketch, include library, add zip library, and move to desktop. We will edit, and everything's done. I will open a sample to verify the code, but I don't upload it to Arduino. Okay, I only want to make sure the library is run correctly. Okay, sample, and move to I will change to Arduino first. File, sample. Here, FreeRTOS. I will open task switching. Okay, right here it includes the library Arduino FreeRTOS.h. this is a library to use FreeRTOS on Arduino, and this is some code, but you need to know what's that. I will show you how to create a task in some next video, but okay, right now I will verify. Okay, good. All over available. It means because this sample use a lot of memory of Arduino. Okay, but don't worry about that. The main point is your library is run correctly, because right here it done compiling, is no any error. Okay. Next, I will show you how to set up in the second way. But first of all, I assume I have not downloaded the library yet. Okay, I will delete it. Delete from document Arduino library, and delete the FreeRTOS library. Delete. Okay, and now I will close and open it again to make sure my FreeRTOS library is deleted. Okay, right here is gone. Okay, and now the second way is download from Arduino library manage. It's very easy. Just open it, sketch, include library, and move to manage library, and search for FreeRTOS. It's too lag because there are many library loads right here. Sorry, FreeRTOS. Okay, the first one, FreeRTOS by Richard Barry. Okay, from this Richard Barry. Okay, just select the version you want to download, and then click install, and wait a little bit. Okay, it's told everything is okay. Now we will check the include library. Right here, FreeRTOS. Okay, you have FreeRTOS library, and now we will try to open a sample. And right here, FreeRTOS, and open one of this analog digital. Okay, it also use Arduino FreeRTOS.h. Okay, now I will verify it. This sample seems to be good. It's not warning low memory as the other before. Okay, and this means your library is run correctly. And then check if the library of here Arduino library is also has the library right here. Okay, that's how to set up FreeRTOS library to Arduino IDE. And now today I will tell you how to use FreeRTOS functions on Arduino. We will know how to create a task, how to handle a task in a period of time so that the program can run concurrently. Okay, now let's go. At the beginning, I will include the FreeRTOS library into our project like this. You can remember this line or include via sketch, include library, and by the FreeRTOS right here. Click on it and it will generate right here. Okay. After include the library, I will give you two samples. The first one I will bring to serial monitor with two tasks. Okay, two tasks is different from each other. And the second, I will control LED and bring to serial monitor at the same time. Code without FreeRTOS and FreeRTOS. Okay, you will see the difference when using FreeRTOS and without FreeRTOS in this video. Okay, let's go. There's some procedure to create some task right here. The first one, I want to create 2 tasks, and I have a first function is void task1. Okay, I will put a task print 1, and I will transfer the parameter right here. We don't need to change any parameter, so I will put void right here. Okay, param, copy and paste. Right here I will change to task print 2. Okay, this is 2 tasks we will code, and then I have to create 2 handle tasks by both of this. Okay, we have task handle T, don't change anything. And now this is the name, you can change anything you want. I will put a task handle 1. Okay, next, copy and paste task handle 2. Okay, this is some procedure, and now we will code inside both of this function. And remember, the function in task will be put below void loop and void setup function. Remember that, because in FreeRTOS we don't need to use void loop, so we don't need to put any code in the void loop. Okay, don't put code right here. Okay, we will code for the task 1, void task print 1. Okay, task print 1, and we don't need to transfer any parameter. I will put void and param. Okay, to inform the program, no, we don't need to use any param. We need to put void and param right here. Okay, easy, right? Next, we need to put infinite loop. Okay, the infinite loop right here is while 1 and like this. You code right here, or you don't want to use while, you can use for double semicolon and code right here. Okay, there are 2 ways to create infinite loop in a task, but I love the first one, so I will delete for. Okay, right here I will put a serial to bring to monitor and a delay time to switch between 2 tasks. Okay, I will put serial monitor serial dot print line task 1, and I will put a delay right here. The procedure of delay is vtask delay until vtask delay 1000 slash protect the period ms right here is millisecond. Okay, this means the Arduino will bring to serial monitor h1 sec. Okay, this is task 1. Okay, I will copy all of this and paste right here. I will change it to task 2 and change it to task 2. Okay, everything like this. Okay, after code something in 2 tasks, we will set up right here. The first one, we have to set up the serial monitor 0.begin 9600 baud rate, and next we will create 2 tasks. Okay, this is the task we want to create. This is the task handle procedure to handle tasks, and we will create a task with the parameter is task print and task handle. Okay, like this. Task create. Right here I will transfer task print 1. Task print 1. Next is the name of task, you can put task 1. And next is the stack memory. You don't need to worry about this. If you do something important or something bigger like the Hulk project, you need to care about this, but this is just an example. Don't need to care about this. Okay, and next is the parameter. Because we don't transfer any parameter in the two of tasks, so we put null right here. And next is priority, I will put 1. And the last one is task handle. We have and right here. Okay, I will copy and paste. We will create 2 tasks. I will put the priority as the same, and I will change it for you to see the difference. Okay, this is project. Create 2 tasks. Print to serial monitor task 1 and task 2 at the same time each 1 second. Okay, let's combine and see what happened. Okay, now I will upload to my Arduino and see what happened in serial monitor. You can see the Arduino print to serial monitor task 1 and task 2 at the same time. You see? At the same time per 1 second. But now we will change the priority. You need to remember like this. The priority is low. The highest priority, it will run first. Okay, I will change the task 2 to 2. And then let's see. The task 2 will print first, and then it will print task 1. Yeah, you can see that task 2 and task 1, task 2 and task 1. Okay, that's in the simple example for print to serial monitor with 2 tasks. You can handle your tasks like this, but instead of using serial monitor, you can control your LED or something. Okay, now let's move to the second example. My second example is control LED and print to serial monitor at the same time. The first one I will use FreeRTOS first, and then I will use normal code with our FreeRTOS. Okay, right here I will control LED via button. Okay, I will comment this code and let create again. I have include Arduino, void task 1, void task 2, but I will change it to task control LED and task print. Okay, and I have to handle task. Okay, task handle 1, task handle 2, and I have void setup. In void setup, I will open serial monitor and set up the pin mode. Default LED is 13 is output. Okay. Next, TaskCreate, I will change the name to task control LED and task print. This is task 1 and task 2, task handle 1, task handle 2. I will put at the same priority. Okay. Okay, right now I will create void loop, but don't put anything. And void task control LED. I don't transfer any parameter. Void param. Okay, I have an infinite loop right here. Okay, right now task control, I will control LED via button. Okay, if digital read, I will use the pin 8 is the button, and I have a while loop here to avoid print too much time. Digital right behind, else digital right low. Okay, And I forgot to put the input right here, pin mod 8 input pull up. Pull up means you don't need to use register with the button. You only need to connect the button to the ground and the pin 8. Okay, this is the task 1. Task controller, and now I will create a TaskBlink. I also don't transfer the param. Have a Y. Sorry, I forgot to put a delay 1 second. End of the infinite. Okay, end of the infinite. Serial monitor 0.print TaskBlink. Okay, right here this is the circuit. I connected the button to the pin 8 and chain D. Now we'll upload the code. Right here we'll put a print line. Okay, let's upload. Okay, done. I will open the serial monitor. You can see that it will print TaskBlink. And now I will try to press the button. Although I press the button, the TaskBlink will print to serial monitor. Okay, because this is FreeRTOS. It will switch between 2 tasks concurrently, so it will not stop the program. Okay, let I show you. I press and release the let it blink. Okay, you could not see that because the TaskBlink is print too much. Now I will clear output and press again. Press. You can see the TaskBlink will print to serial monitor, and I release, it will blink. Press, release, blink. Press, blink. Okay, that's a FreeRTOS. Now I will try code as the normal way. Don't use FreeRTOS and see what happened when I press the button. Okay, now I will delete all of this. I have voice set up. Okay, I will open the serial monitor. Because we don't need to use FreeRTOS, so we don't need to put the FreeRTOS library. Okay, right here we have pin mod 8 input pull up, and pin mod is output. Okay, enough. Right here, if I press the button 8 and why I until press the button, it don't do anything. Okay, if I press the digital right to 13 is low, and else I will turn on LED. Okay, and right here I will print a serial monitor serial.print print. Okay, and delay 1000 in 1 sec. Okay, now I will upload the code and see what happened. Print ln. Okay, and now I will press the button. The program will be stopped, and when I release the button, the program runs. Okay, you can see what happened. That's the reason why they usually use FreeRTOS on Arduino to manage a lot of tasks and in important project. Okay, that's the difference between FreeRTOS and without FreeRTOS. Okay, today I would like to introduce you a new way to use delay, and this new way in this video will help us create a more accurate delay function than the previous one. But I think you should use the old way to build your system first, and when you are sure your system is run correctly, you can add the new way to your system for more professional, because I think the old way will easy for you than the new way. Okay, right here, this is the code in the previous video. Handle two tasks right here, task 1 and task 2 with 1 second. Okay, I will upload code to Arduino and see what happened. Okay, upload. As the priority, it will run at the same time. Task 1, 2, 1, 2, 1, 2. Okay. And each 1 second it will bring to the serial monitor. And now I will add new delay function into this code. Okay, right here I have 3 functions. I will copy it and I will add it to task 1. Okay, right here, passed. The tick type I create a getTick variable and then assign task getTick count into getTick. This is the time the getTick will get time from system tick of OS. Okay, when your program runs, the getTick will get the system tick from the OS to calculate, and then when it count to 1000 minus 1000 divided by per tick per millisecond, it means 1 second, and right here it means it will tick 1000 times, and then it change to the next task. Okay, it's like delay, but it's more accuracy than delay. Okay, cut and paste here, then comment this line. Okay, you could not realize that because it's quite small, but actually this function is more accuracy than the old delay. Okay, trust me. Okay, let's upload and see what happened. It also brings task 1 and task 2 to serial monitor at the same time, like this. Okay, 1 second. If it's not enough 1 sec, it cannot bring to serial monitor at the same time. But right here, it bring at the same time mean the task 1 and task 2 run each 1 second. Okay, and that's how we use the new delay function to create a more accuracy delay for your system. Okay, I will delete it. And now I will give you some new functions in FreeRTOS. You can use it to handle your task if you make your system better. That's a delete function, suspend function, and resume function. Okay, that's a delete, suspend, and resume. Okay, and I will make an example with delete first. Delete function is a function will delete your task in the program. Example, it means you just want to create a task count from 0 to 10, and then you don't want it run in your system anymore. Maybe your reason is save CPU or energy, and you don't want it run anymore in your system. Okay, this is an example. Right here I have a global variable is counter is 0. Okay, and in the task 2 I will count that counter by 1, increase by 1. And if counter by 1, and if counter is 10, I will delete the task. You can choose delete task 1 or task 2, but right here I will delete task 2. Okay, to delete we have v task delete and transfer your task you want to delete to this bracket. Right here, I want to delete task 2. But this is the name of function. You need to find the TaskCreate task 2 right here, task handle 2. Task handle, just pass the task handle 2 into this bracket, and when your system count to 10, it will delete the task 2, and then the task 2 is terminated while the TaskBlink 1 is still running. Okay, let's check. Upload and see what happened. Oh, what happened? Oh, sorry, with task. Okay, upload. Right here, count from 0 to 10. 1, 2, 3, 4. I don't know. But yeah, let's see. Yeah, right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then task 2 is terminated while task 1 still running. Okay, that is the delete function. This function will help you delete a task in your system, and you cannot rerun it again. Okay, remember that you cannot call the TaskBlink 2 again. But in some situation, how can we do this? How can we keep running TaskBlink 2 again? Yeah, that is suspend and resume. You cannot use delete. You need to use suspend to stop your task and then resume it when you want to reuse it. Okay, to rerun the task again, we don't use delete function when terminate. We will use suspend function to stop the task and then use resume function to rerun again. Okay, remember that. The suspend function will stop your task, but your task still there, and you can call resume to run it again. Okay, I will show you how to do it. In task 2, I will suspend it. Task handle 2, it means it will suspend itself. And in the task 1, I still increase counter, and then if counter equal 15, I will resume it by vTask resume and transfer your task you want to resume in the bracket right here. Okay, task handle 2, task handle 2. Okay, let's view it and then upload. Okay, see what happened. The system will run task 2 until 10, and then delete the task 2 until 15, and then it will run task 2 again. Okay, the resume will do this. The resume will help us run the suspend task before. Okay, it run correctly, right? Yes, that is how we use resume and suspend. With these 3 functions, you can create your system better, can help it run better, and you can stop and resume your system. You can do anything you want with your task. And I think the large system need to have OS inside, and the main point is your system will run smoothly than the old way. That's either traditional code. Nowadays they usually use FreeRTOS or OS inside the system to do something better. Today I will introduce you to some new features of FreeRTOS, that is mutex feature. This is a feature very powerful, will help you handle your task. Before we go to this, I have questions like this. As you NULL OS or FreeRTOS run tasks at the same time, right? It means it can run concurrent or parallel. So what happens when 2 or more tasks join into a mission at the same time? It means it doesn't run one task. It runs 2 tasks at the same time. It can join into your data and change the variable at the same time. What data will be assigned if there are 2 tasks run at the same time? Can you guess it? No, you can't guess it, you can't predict it. And this problem hard to debug or predict, right? Okay, I will give you an example of this. I have 4 tasks, task 1, task 2, task 3, and 4. All of the tasks have the same function. That's in task 1 it will change the variable a to 1 and then print to serial monitor. Task 2 also like that, task 3 also like that, task 4 also like that, and then print. Okay, print. And I assume the task 1 will run first. Task 1 will change the variable to 1 and then print the a to serial monitor, right? But it's totally not like that, because in OS the tasks run concurrently and parallel. So this problem can happen. I will give you an example. When the variable a is changed to 1 and it's ready to print to serial monitor, the task 2 will run and it changed the a variable to 2, and then the task 1 keep running and the variable a at that time is 2. Okay, that is the problem. You cannot predict it because the task is run concurrent. Do you understand? That's the problem when you didn't use some feature to handle some task. And I didn't talk about the priority because you can also put the priority of task 1 is 1, 2, 3, 4, and it will run one by one, but the maximum of priority in the system only 15 level. So if you have more than 15 tasks, the problem still happened. Okay, and to avoid that, we have many ways like suspend or resume function at the previous video. But I think that way is not good if there are many tasks are running and it can make your system is delayed or terminated. So in this video, I will give you 2 ways. The first way is a simple way, but this simple way only used for 2 tasks. And the second one is use mutex to handle your system. Okay? Okay, I will introduce you what is mutex right now. And as the Google says mutex is a mutually exclusive flag. It acts as a gatekeeper to a section of code, allowing one thread in and blocking access to all others. This ensures that the code being controlled will only be hit by a single thread at a time. The thread right here is the process or the task. Okay, you can understand like that. I will give a short concept like this. In a certain time, there's only one task run. The other task will wait until that task finish, and that task needs to release the key for the other task. And at that time, the other task can run. Okay, easy, right? Okay, I will give you an example with a picture like this. I have 3 tasks. And I have a mutex key. Mutex key right here is only a variable. It's nothing special, okay? A key. 3 of these tasks has the same function, and of course is add the mutex feature into each function. Okay, I assume that. And okay, I will assume task 1 will run first. Task 1 will get the mutex key, change the a to 1, and then print. Because the task 1 get the mutex key, the task 2 and task 3 will wait until this task release the mutex key. Okay, if the task 1 doesn't release the mutex key, the task 2 and task 3 still wait forever. Okay, after task 1 finish, it needs to release the mutex key, and then task 2 or task 3 can access the mutex key to run the body. Okay, task 2 or task 3, because OS run at the same time, I cannot predict task 2 or task 3 can get a mutex key. Okay, can you get it? Can you get the how the mutex key work? How the mutex feature work? Okay, now I have a code like this. This is the code in the video too. I will put the link in this video description. Okay, now I will create variable a in a, and in a task 1 I will change a to 1 and then print to serial monitor, copy, change to 2 and print to serial monitor. Okay, I will upload it and see what happened. It also run 1 2 1 2 at the same time, and 1 run first, 2 run after that. It not happen to run first because I think Arduino has optimized this problem. But if you use more tasks, can be run 1 3 4 2 5. Okay, I will give you an example like this. 4 in a 0. I have a loop right here to print to serial monitor e variable. Okay, I have 5. And I change this to 50 milliseconds. Copy and then paste right here. Okay, let's see what happened. It will run task 1 and task 2, task 1 and task 2, task 1 and task 2. Okay, right here is task 1, task 2, task 1, task 2, task 1, task 2, task 1, task 2. But if I want to run task 1 and then after finish print to serial monitor, I will run task 2. So how can I do it? Okay, I will give you the first simple way. We have Boolean variable is my mutex bang is false, and right here we have a while loop to check the my mutex. Okay, and the first mutex is false and I want to run the task print first, so I will put the mutex right here is 2. If the mutex is not 2, it will break the loop and run the bodies. So the other, if mutex is 2, it loop right here forever. Okay, this is the mean of this line of code. Okay, I put it false and it doesn't run the while loop. It runs task 1 first, and then I will change the my mutex to 2. The reason is I don't want to run task 1 anymore. I will stop the task 1 and the task 2 will run by while my mutex is false. Okay, and change the my mutex is false. Okay, the system will run like this. First, because the my mutex is false, it run task 1 first, because when it run this line, the system will check the my mutex. The my mutex at this time is false. It doesn't by 2, so it will break the while loop, run the body, and set the my mutex is 2. And then the mutex is 2. This task check the my mutex. If the my mutex is false, it means it doesn't 2. and it breaks this loop. It runs the body and set to false, and then the my mutex is false, and it run like that. It run following the other. Uploading code and see what happened. It will run 0 1 2 3 4 and 0 1 2 3 4. Oh, you can see it. 0 1 2 3 4 0. Oh, sorry, I forgot. In the task, when you have a global variable, you need to put it to volatile. Okay, don't worry about what is the volatile. You need to remember when you use a global variable between the other task, you need to put the volatile in the first of the variable. Okay, I will put the explain a volatile below this video description. Okay, and now let's upload and see what happened. It will run 0 1 2 3 0 1 2 3 4 and then 0 1 2 3 4. Okay, you can see it. 0 1 2 3 4 0 1 2 3 4 1 that's 1 that's 2 that's 1 that's 2 that's 1 that's 2, just like that. Okay, and this is a simple way, and it's only be affected when you use two tasks, but it cannot use when you use too many tasks. Okay, and to use many tasks, I will give you mutex. I have a code like this. I have semaphore handle my mutex. You need to comment this code because I reuse the variable name is my mutex. Okay, semaphore handle my mutex, and then in the setup function, I have a code like this. My mutex is semaphore create mutex. This means I will initialize the mutex. If the mutex cannot create it, it will bring to zero monitor mutex cannot be created. Okay, and then we have a vtask scheduler. Okay, that is the procedure. After that, in each task, we need to get the mutex key and then release the mutex key as the picture I told you. Okay, now let delete my simulate. Okay, I have a function is take the mutex and then release the mutex. Okay, this is the take mutex and this is the release mutex. Take and release. Okay, now let's upload and see what happened. Sorry, I forgot to include mutex library semaphore because the mutex is same as semaphore function, so it also use semaphore library. Okay, it will run 0 1 2 3 0 1 2 3 as my simulate, right? But what happened if I take the mutex
and I don't give the mutex key to the other task?
It only run task 1. The other task will wait until this TaskBlink release the key. If it doesn't release the keys, the other task will wait forever. Okay. Okay, this is the mutex feature. You can apply this function to your system to handle your system. It will help your system run correctly, smooth and perfectly. Thanks for watching this video.